All right, so today our essential question is how can we quantify the amount of gravitational energy that an object has? So we have a little warm up. We want to look at this is our warm up. Take turns answering the questions below with a partner. Compare the gravitational energy of the objects in each scenario below. Which object would have the most gravitational energy in each scenario and why? Bowling ball lifted to a height of 1 meter or a basketball lifted to a height of 1 meter. The bowling ball lifted to a height of 1 meter, or a bowling ball lifted to a height of 2 meters. A hammer lifted to a height of 1 meter on Earth, or a hammer lifted to a height of 1 meter on the moon. So we're going to watch this video. It's linked right here. So after you've watched the video, stop the, well, come back to the slides, and I'm going to explain the answers to these questions, okay? So go ahead and stop the video or watch the video and then come back to this video and I'll talk about the answers. Okay, so now that you're back, a bowling ball lifted to a height of 1 meter. So you have a heavy object, an object that's not so heavy, okay? Okay. All right, so for partner A, the bowling ball has more gravitational energy due to its sheer mass. That's going to weigh much more than the basketball. And then for partner B, the bowling ball that is 2 meters above the ground has more gravitational energy. All right. So this is what we've done so far. We have our problem statement. We've talked over the phenomenon. We've looked at the schematic. We've seen this video play out, so we know that we need to have a system to where Iggy doesn't die. And then we've also done a simulation with a skateboard. So law of conservation of energy. The most important thing to know, that energy cannot be created nor can it be destroyed. We're going to add some things to this packet, to this. We're going to talk about the things that we can get, like the mass of the jumper. That's going to be changing, so that needs to be calculated every time that we have a new person jumping. Same thing with the starting height. Not everyone's going to be the same height. All right. So we're going to color code these things, okay? At this next slide. So you need to write down everything that we have here. Input for users, that's each jump. They're going to change. I have a calculation here. We're going to do a mini lab. We're going to do that the next time we meet, probably next week. Calculate the mathematical model. These are going to be inputs, height of the jumper and the ending height. And then we turn to page 9 of your packet. So you need to figure out, the diagram below shows 3 kilogram masses, and A and B show a spring scale holding the 1 kilogram mass at the height of 2 meters and 1 meter. C shows the mass on the floor. Create a ranking to compare the force of gravity on 1 kilogram mass. Okay, the force of gravity. So basically they're asking you, does A have more gravitational force than B? And then does B have more gravitational force than C? Okay, and you need to rank these, okay? This one, gravitational potential energy, we touched on that in the warm-up, okay? So you can listen to that. And so these need to be ranked here and here. And then I would like you to explain your ranking. Okay. All right, so warm up, revisit. Let's go. Try to figure out the differences so we can understand what's involved in gravitational potential energy. A bowling ball lifted to a height of 1 meter or a basketball lifted to a height of 1 meter. Which one has more gravitational energy? What is the difference between them? Okay, so they're both at a 1 meter. Okay, and there's a formula for this, and that is in your packet. For this one, you need to find the difference so we can understand what's involved in gravitational potential energy. And this is the EG is gravitational potential energy. So you have mass And then you have the gravity, like on Earth is 9.8. What's the mass on other planets? And this one is a bowling ball lifted to a height of 1 meter, or a bowling ball lifted to a height of 2 meters. This one is the mass of the bowling ball, the gravity on Earth, height that is lifted. Okay, so you just did dimensional analysis, and you're going to do more of dimensional analysis in chemistry, so get comfortable with it. Okay, so let's see how strong our planet is. Okay, so how much force does Earth pull on a 1 kilogram weight? How much force does the Earth pull on a 2 kilogram weight and 3 kilogram weight? Gravitational field strength is the force of gravity per kilogram of mass. So we will go through that. Let me just... Okay, so here we have gravitational field strength of our celestial objects in the sky. And our sun has the strongest gravitational field strength. And which object has the least gravitational field strength? So that would be, what, 0.49? 0.27. That would be Ceres. All right. So I'm not going to show the answers to this just yet. Now you have them. Okay. So the force is the same in all three places because we're on Earth. It's the gravitational force is 9.8 here, 9.8 here, 9.8. Okay. The gravitational, this is how it should set up, CBA. And it's this way because this is on the ground. It has no gravitational potential energy. And if you remember from our bungee jump schematic, when we're doing the energy bar charts, note how if you're like comparison to this one's halfway between A and C. So this one has a little bit less gravitational energy than this one, okay, in comparison. And these are the equations that you were going to have to write down. So you have kilograms times 9.8 newtons, kilogram, and then when we do the math, we cross out the kilograms and we're left with newtons, okay? And I'll put these up on the board and we'll talk about them. What factors determine the strength of a force of gravity acting on an object? We talked about it. Were you paying attention? What factors determine the amount of gravitational potential energy that an object has? We talked about it. Were you paying attention? All right, so here we have the answers. Please attempt them yourselves before you go on to the answers. We have this slide here, just kind of sums it up. Mass, gravity, height. For gravitational potential energy, you need height in there. And next time I see you, we're going to start this elastic lab. Hope you have a good day.